we are proceeding with the Advanced Financial Management Revision, and today I want us to look at the topic of the portfolio theory and analysis. And the first question I would like us to discuss today will come from August 2022. August 2022, question 1b. So the question will come from August 2022, question 1b. This is the question I would like us to go through. And the question reads that an investor has decided to invest shillings 2 million in the shares of two companies, namely Dera Limited and Alpha Limited. The projection of the return from the shares of the two companies, along with their associated probabilities, are as follows. You are given the probability, and then you are given the returns. Then from there required, determine the proportion of each of the above shares required to formulate a minimum risk portfolio. Then Roman 2, the amount in shillings that should be invested in each share using the proportion determined in B Roman 1 above. So that's what we have. So this is the information that we are given, that our probability, we are told that our probability, and then we have the return in percentage. So here 0.20, so here we have Dera Limited, and here we have Alpha Limited. So then here we are given 6, and here we are given 8, then 0.25, we are given 7, we are given 5, then 0.25, here we are given negative 3.5, and here is 14, then 0.30, here we are given 14, and here we are given negative 1. Then they need the proportion. They need the proportion. So the first step in this case is for us to get the expected return. So how do we get the expected return? Let Dera Limited be represented by D. So our expected return of D will be given by what? Will be given by the summation of the return, then you multiply by the probability. You multiply by the probability. So in this case, so we have them. So we start with the D. So it is 6 times 0.20 plus, we talk about the summation, 7 times 0.25 plus, then this is negative 3.5. You multiply by 0.25, then plus 14 times what? 0.30. So therefore in that case, how much are we going to get? So in this case, you will get 6.275%. Then from there, let alpha be presented by A. So we are going to get the expected return of A. So our expected return of A will be given by what? Again the summation, 8 times 0.20 plus 5 times 0.25 plus 14 times 0.25 plus minus 1 times 0.30. So in that case, how much are you going to get? So in this case, you will get 6.05%. 6.05%. Now, let us go to Roman 1. Let us go to Roman 1. So in Roman 1, we are told that determine the proportion. Determine the proportion of each of the above shares required to formulate a minimum risk portfolio. So how are we going to get the weight? For example, we have Dera Limited and Alpha Limited. If we want to get the weight of Dera Limited, will be given by what? Will be given by the standard deviation of A squared minus the covariance of A and what? And D. Then from there you divide by the variance of A squared plus variance of D squared minus 2 covariance of A and what? And D. A and D. A and D. So that is how we are going to compute that. So let us compute our we haven't computed the standard deviation squared, then we compute the covariance. Let us get the standard deviation. For example, of A, let us start with A. So how do we get the standard deviation of A? Is given by the square root, where we have again the summation of the return of A minus the expected return of A. Then you square, you multiply by the probability. You multiply by the probability. So in this case, our return of A, we have what? We have 8, then 5, 14 and negative 1. Minus, we got 6.05. 6.05 and 6.05. Then once we get these, we square. Then we multiply by the probability. The probability was 0.20. This one is 0.25, 0.25, and 0.30. So therefore, how much? How much are we arriving at? Let us see how much we are going to get. So in this case, we will take 8 minus 6.05. Then we square times 0.2. So the first case, we are going to get 0.7605. We go to the next one, is 5 minus 6.05, you square, times 0.25. So this one will be 0.27. 6. Then the next one is 14 minus 6.05 u square times what? 0.25. So this one will be 15.8006. And finally we have negative 1 minus 6.05. Then you square, then you multiply by 0.3. So this will be 14.9108. Then we get the summation. So our summation will be 14.9108 plus 15.8006 plus 0.2756 plus 0.7605. In this case, we are going to get 31.7475. That is what we are having. So remember, what we have computed is the variance without getting what? The square root. And that is what the examiner wants, the variance of A. Then once we compute the variance of A, let us get the variance of B. Variance of B, in this case, will be given by what? It is again the summation of the return of, remember it is not B, but D. It is supposed to be D. We are talking about D. So D here, it will be the summation of D minus the expected return of D, then you square times what? Probability. So we have it here. We have 6, 7, minus 3.5, then 14. Minus. Here we have what? 6.275. 6.275 and 6.275. This is what we have. Then we square. Then we multiply by the probability, 0.20. Then here you multiply by 0.25. 0.25 and 0.30. So how much are we gonna get in this case? So it will be, here we are going to have 6 minus 6.275, then you square times 0.2. So here we will get 0.0151. Then the next one is 7 minus 6.275 square times 0.25. So here we are getting 0.1314. Next one is minus 3.5 minus 6.275, then you square times 0.25. In this case, you are going to get 23.8877. Then next one is 14 minus 6.275, you square times 0.3. So here is 17.9027. Then you get the total. The total will be 0.0151 plus 0.1314 plus 23.8877. Then you add 17.9027. So you get a total of how much? We are getting 41.9369. That again is our variance. This is our variance of what? variance of D. This is our variance of D. The variance of D. That is what we have. So once we have the variances, what is remaining is for us to compute what? The covariance of A and D. Covariance of A and D. So let us compute the covariance of A and D. The covariance of A and D. The covariance of A and D. Covariance of A and D. Remember, we have to retain this. This is our expected return of D. But we don't need the expected return. What we need is the standard deviation square. So therefore, now let us compute the covariance. Covariance of A and D. The covariance of A and D will be given by the summation of what? Of the return of A minus the expected return of A. Then we have the return of D minus expected return of D. Then you don't square, you multiply by the probability. In this case, you multiply by the probability, that way. So we have those figures, the figures are here. So for A, we had 8, then 5, then we have 14, and negative 1, minus, we had 6.05, 6.05, 6.05, and 6.05. Then from there, the next one is delta. Delta is 6, 7, then negative 3.5, then 14. Then from there minus 6.275, 6.275, 6.275, then 6.275, then times 0.20, then you multiply by 0.25, 0.25, and 0.30. So how much are we going to get here? So the first one, let us compute that and see how much are we getting. So it will be 8 minus 6.05. Then we had 6 minus 6.275. Then times 0.2. So the first one will be negative 0.1073. Then the next one will be 5 minus 6.05. Then we had 7 minus 6.275. Then we multiply by 0.25. So this one will give us again negative 0.1903. Then we go to the next one, 14 minus 6.05. Then we have negative 3.5 minus 6.275. Then times 0.25. So this one will give us minus 19.42, then 78. Then next one is minus 1, minus 6.05. Then we have 14 minus 6.275. Then you multiply by 0.3. So this one, negative 16.3384. Then we get the total. We sum them up. So when we sum them up, we have minus 0.10 0.73 minus 0.01, 1903, then minus 19.4278, and also minus 16.3384. So the total will be minus 36.0638. That is what we have. That is our covariance of A and D. Once we have the covariance, now we can get our weight of D. Our weight of D is given by the variance of A. The variance of A was 31.7475. Then minus the covariance. So it will be minus 36.0638. Then from there you divide by the variance of A, which is 31.7475. Then plus D, 41.93, then 69. Then we have what? Plus, it will change to positive because minus will be positive. 2 times what? 36.0638. So when we simplify this, it will be how much? It is 31.7475 plus 36.0638. So this will be 67.8388. Then we divide by this one, it is 2 times 36.0638. Then from there plus 41.9369 plus 31.7475 equals. So this one you will get 145.81, then 20. So therefore take 67.8388, 67.8388 divided by 145.8120. So in this case, we'll get how much? So our weight of D will be 0.4652, which in our percentage you multiply by 100, it will be 46.52%. Then from there, our weight of A will be 100 minus 46.52%. So in this case, how much are you gonna get? So it is 1 minus the answer times 100. So in this case, we will get 53.48%. So those are the weight of, remember, we said that D to present what? Data, limited. And A to present what? Alpha, limited. So the weight of data limited is this one. And the weight of alpha limited is that one. And that was the Roman 1 of this question. Roman 1 of this question, that is how you are supposed to compute it. Then from there, we want to compute Roman 2. Roman 2. Let us compute Roman 2. Let us compute Roman 2. We want to compute Roman 2. We want to compute Roman 2. Let us see Roman 2, what the examiner wants. So we want to compute Roman 2. So for the case of the Roman 2, the examiner is asking the amount in shillings that should be invested in shares using the proportion determined in B Roman 1 above. So they want what? They want the amount in shillings. Remember, the total amount to invest, total amount to invest. The total amount to invest was shillings 2 million. 2 million. So therefore the question is, how much is Dera Limited going to get? So Dera Limited will get 2 million, then you multiply by 46 point what? 0.52. So therefore, in this case, Dera Limited will get how many shillings? Let me see, Dera Limited will get how many shillings? It is 2 million times 46.52%. So you will get 930,400. Then from there, let us see Alpha Limited will get how much? 2 million. 2 million. Then you multiply by 53 point what? 48%. So therefore, in this case, this one will get how many shillings? It will be 2 million times 53.48%. So you will get 10,600 shillings. So that is the amount. That is the amount. That is what the examiner required in this question. That is what the examiner required in this question of portfolio theory and analysis. Portfolio theory and analysis. My good students, what you should remember always, once you are asked about the weight of two stocks, and this is some of the kind of information provided. Remember that we have said our formula of computing the weight. If you need the weight, for example, you had stock A and B, you need the weight of what? Weight of A will be given by the variance of what? A, B, then minus the covariance of A and what? And B. Then you divide by what? You divide by the variance of A, then you add the variance of B, then you raise what? 2 covariance of A and B. So once you get the weight of A, now you can get the weight of B. The weight of B will be given by 1 minus weight of A. That is what you are supposed to remember. This is what you are supposed to remember. So ensure always you are able to remember this kind of the formula. It is a very easy formula, and with the practice you can be able to remember it easily. So once we have done that question, I want us to look at the next question for today. And the next question for today will come from August 2023. The next question for today will come from August 2023. The next question I would like us to look at will come from August 2023. August 2023. The next question is August 2023. Question number August 2023, question number 1C. Question number 1C. This is the second question I would like us to work out today.